I'm really glad to have you here for the fourth edition of the OpenSIPS Summit. And I will do for 50 minutes on some kind of keynotes, short introduction into what we will do today, a bit about OpenSIPS, latest news, and then we will continue with the speakers with more really important, interesting presentations and workshops. Most of them are actually focused on OpenSIPS and Asterisk because, okay, we are, most of us here because of the Astricon. So let's pay our respects to Asterisk.
That sounds very morbid.
Well, it just came out that way. Yeah, so just to be sure, I'm pretty sure that most of you do have an idea about what OpenSIPS is, what you can do with it. But first, a couple of things about OpenSIPS, just to be sure that everybody is on the same page, because we had surprises like people still making confusion between let's say OpenSIPS, Asterisk, Free Switch, and so on. So they don't know exactly where they fit into the big picture. So the only thing that you have to remember about OpenSIPS, it's more or less it's a generic SIP proxy, or let's say SIP server, because it's somewhere between actually covering class 4 and a bit of class 5. We can do also a lot of class 5 features as time as they are signaling related, so they don't have anything to do with media. Because that's it, with OpenSIPS you cannot do media at all. So we are somewhere in the middle of the VoIP ecosystem, between endpoints, gateways, application servers, other media servers, and SIP switches. So basically, OpenSIPS offers you the core of a VoIP platform, interacting and sharing you the interaction between all these SIP entities. Of course, talking only SIP. And yeah, answering let's say to quite a popular question like why should I use OpenSIPS, or what makes OpenSIPS so interesting for the VoIP platforms? Well, we have three important reasons for choosing OpenSIPS, starting from the ability to deliver high throughput on the voice over IP systems, because probably you are part of you are used with Asterisk, being able to do a couple of hundreds of calls, to do a couple of tens of calls per second, and so on. So with the let's say small medium services, but with OpenSIPS we go to the carrier grade size. We are able to do like tens of thousands of calls per second and handle millions of parallel calls and so on. So we have a really high throughput on the system. So if you need something like that, then definitely OpenSIPS is for you. Then it's about the flexibility in routing and integration. The way you can configure OpenSIPS is very flexible. You are not limited to certain scenario. Basically, you let's say you write your own configuration, like using something similar to a programming language. So you can describe into OpenSIPS what exactly you want to have. So you have a large liberty in doing that. And this ability to use scripting in order to, let's say, instruct OpenSIPS what to do, combined with the presence of more than 100 modules that do offer different kinds of functionalities in terms of routing, functionalities in terms of backends, database backends, NoSQL, SQL, and so on, or different kind of engines. So you have a large set of modules offering a large set of features to the OpenSIPS features that you can take and combine into your routing script and achieve whatever you can think of when in terms of services. So, a couple of things about the project. Probably familiar with that, about the open source, about the community, about, let's say, the openness we have in terms of deciding what to do, how to do, and when to do. Everything is more or less subject to discussions. And we have to admit that somehow we are, how to say, addicted to making OpenSIPS if I can say so, an industry-loved tool. So our target is to deliver a carrier-grade telco-like oriented software to be used by the industry. For any kind of project, the most important part are the knowledge transfer. More or less, that's why we are here right now, because maybe OpenSIPS is you go and buy a Lamborghini. That's not enough. You have to learn how to drive it. So you need to achieve a bit of the skills in order to use such a car. So OpenSIPS is a quite powerful engine, and you have to understand a lot of things about SIP and OpenSIPS in order to be able to use it at with the maximum efficiency. So that's why the knowledge transfer it's a key part for the project. So we have the documentation and online manuals. We have the advanced tutorials addressing certain points like integration with Asterisk, integration with FreeSwitch, how to do call centers and so on. We have the webinars, very active mailing list and IRC channels where you can get help and support from the community. We have the e-bootcamp training and certification program, and also this kind of summits, which are like half sharing experience about OpenSIPS, half showing you different kind of doing workshops about real life scenarios and how to implement and going into the details. Now I will dive a bit into OpenSIPS 1.11, which is the latest stable release. So just to give you a quick tour with what's available in 1.11. 1.11 became stable on this year, on the 8th of May. And as a direct effect, 1.9 is no longer maintained, so it's unmaintained version. And 1.8, which is an ATS, and 1.10, they're still maintained until 1.12 will be on the market. So basically, the idea is don't use 1.9 anymore, or maybe not even 1.10. Then it's a short-term release, so it will be obsolete quite soon. So focus on 1.11, which is a long-term supported release. What we have in 1.11, we have working in different areas, working in the low-level part under the hood, doing a lot of work in optimizing things, addressing different kind of bottlenecks into the application, because part of our goal is to maintain this high throughput. At the same time, we also want to address the high-level side when it comes about what kind of features, functionalities, routing logics, and so on you may have available into the script. So there's a lot of work into the memory manager, because this memory manager maybe sounds like something trivial. Nobody cares about memory manager, but actually it proves to be quite a big bottleneck. I mean, when you have a multi-process application that needs to share a lot of information, and you expect like 50,000 calls per second, memory actually synchronizing at the memory level becomes a penalty. So we did a lot of work we actually reworked the memory manager in a different way to increase the level of parallelism into this manager, so to get a higher throughput. Also, there was a lot of work in a similar way in the transaction module and in the TCP part, in the TCP stack. Once again, the idea was the same, not to have bottlenecks, because all these resources needs to be managed. And once again, you have a multi-process environment. Things need to be synchronized, shared, and such processes like synchronizing or sharing process may become a bottleneck into an application. So what we did was, once again, reworking all these in such a way that we increase the level of parallel computation in the transaction module and in the TCP stack. Also, there were a lot of enhancements. General enhancements, first addressing the scripting part, like simplifying or making it more friendly. Like, trying to, as let's say, overall recipe was, first of all, trying to get rid of global parameters for the modules, because this reduces the flexibility. Like sometimes maybe you want to use a location with or without modules, or without, domain. So in that case, if you do it module parameter, you don't have the flexibility to do it in both ways at the same time. So global parameters were moved as flags or parameters to the actual functions to give you better flexibility. We have for each statement to help you with the looping, because sometimes processing in the script becomes more and more complicated or complex, let's say, and you actually need such functionality. Also in the scripting, functions may have what we call the missing parameters. Sometimes you have a function that may take quite a large set of parameters. Some of them are optional. And just to be clear which are missing or not, we had to introduce the concept of empty parameter, just to mention, okay, that's a slot for one parameter, so just to know exactly which one goes where, but so you don't have to provide it. Because otherwise, you all the time, oh, my function has 2 or 3 or 4, but which one, it's the extra. You don't know exactly which parameters you're actually pushing because of missing order. In this one, you have a fixed template for the function, prototype, so you know exactly which parameters are used. Something important for clustering, we have the replication added for the registration process. In the previous, in 1.10, we had this replication via the binary interface for the dialog support. So basically replicating the dialog information, the metadata for the dialog. For the dialogues between OpenSIPS instances. Now we extended for the registrations. So basically all the registration in OpenSIPS can be transparent for you at the script level, replicated with one or multiple other OpenSIPS instances via this binary interface. So you don't have to care about it at the script level anymore. The metadata about the registrations are automatically shared between OpenSIPS instances. Something very important, we have this new module which is called Script Helper. And this Script Helper module wants to address actually this steep part of the learning curve. Because as I said in the beginning, it's quite, you have to do a lot of, you have to understand and assimilate a lot of knowledge about OpenSIPS. You have to start understanding SIP, first of all, in details, SIP at messaging level, transaction level, dialog level, and so on. And then you have to move on with understanding OpenSIPS itself, how to work, how to do routing, and what the routes are good for, and so on. So this script module actually helps you with the learning, because it's a wrapper on top of your script, hiding different kind of, let's say, standard things for your that you typically do in OpenSIPS, like how to treat a cancel, how to handle sequential requests, how to enable or disable dialog support, or how to handle match reversal, and so on. So you don't have to actually implement such things explicitly in the config file. You just have to enable this script helper module, and this module will do all of them for you. So you're in the very, very beginning, let's say you are a newbie, you go there, use this module, and you can focus actually on the routing logic. So let's say to achieve whatever you want to do, some service logic for you. And once you did that and you see it works, then you can remove the script helper. You can start looking behind and understand more and more. But the idea in the first steps, it's hide all the complicated things, gives you just the will, so you can control the system. And that's it. After that, if you want to, you can look under the hood and see how it's done. But that's the purpose of this script helper module. Also on the high level end, we have starting with 1.11 the call center module, which is actually a call queuing system. We have a lot of people trying to do different kind of integration. OpenSIPS with Asterisk, trying to solve the problem with queuing, scaling the queuing into Asterisk. So at the end we said, okay, actually the whole queuing thing, it's more or less a signaling problem. So you have to do it at the signaling level. So why not? We can do it actually directly into OpenSIPS. So using the back-to-back engine that we have in OpenSIPS, we have a call queuing system. So for monitoring agents, distributing calls between agents, queuing calls, and so on, directly into OpenSIPS. This call center kind of module works with, you need an external media server, but just for injecting the RTP. So let's say using Asterisk or FreeSwitch or whatever you like, just for doing the actual streaming, like for announcements, for the call queuing, and so on. So once again, tracking agents, distributing the calls across agents, implementing the priorities between the queued calls and so on. Everything is done into OpenSIPS. And starting with 1.11 for also for integration purposes, we have in the management interface, we have JSON support. So actually you can talk JSON directly with OpenSIPS, like sending commands and getting responses. That's a huge advantage because it's what you have, it's a structured output. So instead of being a simple text output that you have to parse and handle, then it's output it's generated in a JSON format, so it's very easy to understand by other application to parse and so on. There is share call appearance, which is a quite popular feature, and now it's available also for the back-to-back part. Previously, it was only in the proxy mode. So there was a lot of work in 1.11, both performance and high-level features. So let's see exactly what were the results, at least in the performance review. So when we are talking about performance, basically, what are we fighting against? And this is the Amdahl's law about basically here you have the number of processors, the machine, the hardware, basically the hardware resources, and here you have the number of you can see the number. You can see the speed up of an application based on the number of processors. And Amdahl law says that at some point, even if you have a huge number of processors, you get a flat line. So you are not able to scale anymore with the hardware. And it's pretty logic because even if you say yes, I want to use 1,000 processes, and even if the machine has the resources to run 100 processes. The problem with these 100 processes are a single application, and they have to share a lot of information between. So you have bottlenecks, as I said before, in synchronizing and sharing between all these applications, and that's what Amdahl law shows here. So this is with a memory, with this memory allocation, with the work on the SIP layer. We had, as I said before, the transaction and TCP stuff. We have the results right now. So we managed to boost the performance on the same hardware. So what we were able to do before, like 25,000 calls per second, right now we got to 60,000 calls per second with a single OpenSIPS instance on an IBM server, and actually using just 50% of the CPU, because at that volume of traffic, then you start hitting problems with network cards, bandwidth, and stuff like that. 60,000 calls per second, it's a huge amount of traffic. In terms of concurrent calls, you can go easy up to 5 million calls.
Is that with the dialog module or stateless? Is that with the dialog module or stateless?
No, if it's stateless, doesn't count, right? No, that's with dialog module and with the database persistency. Because there are a lot of work done in pushing everything into the database, and also recovering from the database, the dialogues and so on. So right now you can score at the signaling speaking 5 million concurrent calls on a single instance, and also with the new work on the rework of the TCP stuff stack, you can get like maybe half a million TCP connections from mobile end users. I'm saying mobile end users because these are particularly, let's say, demanding in terms of resources. Like if you run a SIP client on a mobile device, then it will quite, if I can say so, abuse the TCP side in terms of connection, how many messages they send, doing keep alive quite often, and so on. So they'll put actually a lot of load and stress on the system. Not to mention that you have to be careful in handling the TCP connections, because a mobile device can disappear from the network in terms of seconds, so you can have a lot of zombie TCP connections that you have to deal with, and so on. So that's what we managed to address to actually achieve in terms of persistency with the 1.11. And now, okay, that's the current point, and I would like to dive in what are the next, what's on the table for the next release. And actually, the next stable release will be 2.1, because we already shifted from 1 point whatever to 2 point whatever. And this happened because we actually started importing a lot of functionalities and code from what we call the OpenSIPS experimental code, which is developed based on the new design with a completely different approach, internal architecture of OpenSIPS, basically to address some, I wouldn't say problems, but more or less issues that we currently have with the design. The design of the current design we have into OpenSIPS is more like 10 years old, and it was done when basically there was only UDP, and there was no need for so much sharing of data and so on. And at that very moment, the decision was good, but it's not keeping up with the current requirements. So that basically requires a completely rework of what we have under the hood. And we have this new design, an OpenSIPS experimental code. It's a kind of a playground where we test and validate different kinds of concepts. And when they are approved, they are ported into the OpenSIPS mainstream. So basically, into what ends up into the main in the stable releases. So with OpenSIPS 2.1, the change actually marks the first, let's say, the first migration of code from the experimental to the mainstream, with the I/O asynchronous reactor, so to be able to do non-blocking operations to DNS, to the databases, and so on. with a different approach on how internal tasks are distributed across processes, so the mapping between jobs and processes, because managing resources, available resources, and being able to use all the available threads is something very, very important. Also about dealing with the timers, because you end up doing more and more and more and more operations on the timers, and that becomes kind of a bottleneck. So we had to rework completely the timers. So instead of having dedicated processes, well, we simplify the jobs to all the worker processes. And to be able to do more high-level features, we had to add the concept of a context to see messages and transactions. So basically to give the liberty of different kind of applications to attach custom data to SIG messages or to transactions. For example, that's required for some new work related to SIG message encoding or compression. So this is the first porting from the OpenSIPS experimental to the mainstream, and that's why we have the shifting from 1 point to the 2 point, because it reflects this new era in the OpenSIPS architecture. With asynchronous operations, first step is about supporting asynchronous operation from the script, like you trigger maybe a RESTful query, or you do a database operation, or you execute an external script and you don't want to actually have your OpenSIPS blocking and waiting for that external operation to wait. So you want to evaluate the resources, allow OpenSIPS to do something else while waiting. So that's what will be available in 2.1, and slowly will become more and more generic, so to be used also internally. But first would be to allow asynchronous operation at the script level. More things in 2.1, high-level things. We have the quality-based routing module. Right now, everybody does least cost routing, prefix-based routing, and so on. So we add a new concept of the quality-based routing module, where we collect information about the ongoing calls to different gateways, different parameters, like the ASR, the PDD, ACP, and so on, to see exactly what was the quality, once again at the signaling level of the calls, and then we are able to dynamically choose the best gateway as parameters from the list. So all the time you can do something like, okay, I want to do routing in such a way that I want to offer the best quality to my customer. And all this information, once again, are real-time collected by OpenSIPS based on the traffic, and then used in order to do routing. Another thing, we have this partitioning of routing data. We have a lot of modules, like dispatching. You go there and you define a set of dispatching. You have the dynamic routing where you can set together, you can define a lot of information about how to do the routing. You have the dialog module where you can go and define different kind of groups and so on. And using just the concept of a set or group should be not be enough, because we ended up using, just to give you an example, dynamic routing module, using it in the same time for the actual routing, prefix-based routing to the gateway, but in the same time to use it for billing, to do the prefix-based matching, but on a different set of data, which are exclusively for billing purposes, so completely different set. So there was a need also for the dispatching, in some cases also for the dynamic routing, to have completely different instances of data. One used for, let's say, for routing, the other one for billing, for dispatching, to have a dispatching, let's say, used for the trunks, another one for the internal resources, and so on. So that's why we come up with an extra layer on top, with another way of grouping data, which is the partitioning. So dynamic routing, dispatching, and output right now do support in 2.1 the concept of partitioning, which means you can use in parallel different sets of data at the database level in the same time. Another really important thing is the fraud detection module. Flavio will give you a really scary presentation about fraud detection. And this is a module in OpenSIPS that wants to start offering some basic abilities to do the fraud detection. The idea is to define calling profiles and to assign to your end users such profiles. So calling profile basically is what are the calling patterns of the user, like what areas the user usually dials, what are the working intervals, like okay, if it's a company, it works from 8 to 6 p.m., whatever it's after that, it may be a suspicious call. So you can define such rules. Also about number of, let's say, simultaneous calls, or what's the calling rate. You know, you have a company and you say okay, usually they do like 2 or 3 calls per second, right, overall, and you see a spike of 10 or 20 calls per second, then that's maybe an alarm, and it fits into this fraud detection that maybe someone hijacked the company account and it's pushing calls. So that's a module that using these kind of profiles tries to detect abnormal patterns in calling and to detect this kind of frauds. Another thing is the SIP compression, because there are cases where it's really needed to have the ability of doing compression. It's not necessary for the let's say for optimizing the bandwidth usage, but it's also for optimizing the routing and also to minimize resources when it comes to the routing into a SIP platform. Because right now, probably there are just a few systems where you have only one SIP engine, SIP server, let's say SIP server into the platform. Usually you have an edge element, you have a SIP core, then maybe you have something in the background presence and something doing routing and so on. So you have multiple entities in your platform. And if you have an uncompressed message with a lot of dangling information attached to it, like headers which are used only by the endpoints, for example, or SDP and you don't care about the SDP, right? Because you're just routing, doing signaling. So all these kind of things can be compacted and compressed when the message gets into your platform. It's carried as a simple body, nobody looks into it, you don't waste time parsing it, you don't waste time looking at it and nothing like that. And you just may uncompress it when the message leaves your platform. So you save a lot of bandwidth and a lot of processing. There are also standards about things that can or cannot be compressed. For example, in SIP you have the short name versioning. And you have so instead of having VI, you put a V. Instead of from, you have F, the short version of the headers. Also, you have headers with multiple instances, like VR, route, headers, and so on. So you can combine in a same payload in a shorter format using short name for headers, combining headers with the same name, and so on. So you can do these kind of tricks to reduce the length of the SIP message, and that is something useful, for example, when in the relation with the endpoints, because even today there are cases where you have a lot of on the endpoints you have a lot of UDP stacks which have problems with UDP fragmentation. So you want to try to stay inside the NTU size. So So sometimes even like a couple of bytes are really important not to hit the fragmentation point. So this kind of things will be available in OpenSIPS 2.1. The zip-Y is kind of compacting, but also compressing, actually, like using like zipping the content of the body, so just to make it shorter while it's moving across the platform. So all these will be available in 2.1. And also some work about the transport protocols, because everybody right now is everybody's talking about doing running services in the cloud. And when you do that, you're actually using kind of, let's say, private networks. So even if your service is reachable via public IPs, your actual OpenSIPS sits on a private IP, so you need to deal with this kind of communication. So to make OpenSIPS advertising and the public interface, maybe at the same time you have to deal with the public and the private interface. So you need a lot of flexibility to deal with such kind of route. So we are, let's say, trying to simplify all these things in the 2.1 version. So that was the main goal for this introductory part. First, to see exactly where we are in terms of 1.11, and the second one is what will be available in the next release, or what we are working on. It's the OpenSIPS 2.1. This release will become available probably somewhere in February next year, because all this porting stuff from the OpenSIPS experimental actually consumes a bit more time than a normal release. There is a lot of testing to be done and so on. So probably will be an overstretched release in terms of timing. But at the end, if you look at the results, I would say that it really pays off all this effort and waiting. So that's from my side. If you have any questions about this part, I'll be glad to. Yes.
So 2.1, is that the merge between like 1.11 and 2.0?
It's not a full merge. It's I would say a partial merge, because not all the things from the experimental branch were imported. Some of them are still experimental. I mean, we're still working. For example, the concept of migrating from processes to threads, or using exclusively shared memory against the private memories and so on. So this kind of, or doing real-time changes over the messages, like in the experimental code. So these are still, let's say, kept back, maybe for the next releases. So we will take them one by one and import it into the mainstream, just to see, I mean, first to be sure that whatever is imported is correct, and also, how to say, not to create a radically different version, because we have to think about what would be the impact of releasing such, let's say, different code of all the production systems. I don't want to have people feeling uncomfortable. Right now I have I have an old Ford, and tomorrow I have a Lamborghini. I don't feel comfortable, behind the wheel with a completely different car. So we want to give some comfort to the people, and to make easier the migration between the versions. So that's why we said, okay, probably this process of testing, importing will span over a couple of years. But we said that's the best way to do it.
So what are the things that are actually being merged from 2.0 to 2.1?
There was this one. So this is part of the first porting, so basically the asynchronous reactor, and the way how the internal jobs are distributed between the processes. So instead of having dedicated processes for like UDP reading, TCP reading, for timers and so on, You have just a single pool of workers, and then jobs are generated and dispatched across the rather than dedicated processes. Okay? Yep.
We're going to have something like a reload instead of this entire restart of the system in the new version.
Sorry, come again?
If we are going to have some kind of reload instead of the entire restart of all processes in the new version.
Yeah, you mean for the config file?
Yeah, to not have to restart the entire system in case we have to make some changes.
Yeah, that's something that is in the OpenSIPS experimental. Like the whole config file is actually split in two parts. One is, let's say, defining the interfaces, which are more or less should not be changed. And the second part is the routing logic. So all this, like you have right now, the routes, right? So this, with this still having the same set of listeners and network configuration and so on, you may have the ability to reload the routing logic only. So that part is in the experimental code, and probably will be somewhere later to be imported. But yeah, it's on the to-do. Unfortunately, it cannot be one of the first because it depends on a lot of other changes, like context and so on. So you have to, how to say, to have a completely different approach on the coding in order to, have the ability to reload the config file. Because right now, everywhere in the code, everybody assumes the config never changes, right? So you have to address all these problems one by one everywhere, and then to make it change. Okay, if there are no more questions, then we can, first I would say thank you. And next speaker is Ali Bey, and from J2. He will give us a bit of more information about the OpenSIPS config file, because I guess that's the trickiest part for most of the people.